In this lesson, we're going to learn about rate of change, and more specifically, we're going to find out how to find the rate of change from a table of values and from a graph. Rate of change is a measurement of how one variable might change in relation to another variable. An example of this is speed. We know that speed is equal to distance divided by time. So speed is a rate of change. It's a measurement of how the distance changes over time, and it can be measured in kilometers per hour. Another example would be an hourly wage. If someone works a part-time job and earns $10 per hour, that's the rate of change. They will earn $10 for every hour. But how do we find a rate of change from a table of values? So let's look at this first example here. The Student Council is hosting a spring carnival for all students. They charge an entrance fee to get into the carnival and a cost per game. What do they charge per game? So the rate of change in this case is the cost per game. That's how much it costs to play one game. Let's look at our table. If we play 0 games, it costs $5. Well, does that even seem fair? Well, actually it does, because according to this, the Student Council charges an entrance fee. That's a cost to get into the carnival. So this $5 is the entrance fee. And if we play 5 games, it costs a total of $7.50, which includes this entrance fee. And if we play 10 games, it costs a total of $10. And if we play 15 games, it costs a total of $12.50, and then this table will just continue. So to find the rate of change, and in this case, it's going to be the cost per game, we want to find out how much our cost is increasing by compared to how much our games are increasing by. And to do that in a table of values, we want to find out how much each row is going up by. So if we look at the number of games, we can see that these are all going up by 5. So we know the number of games that are played goes up by 5, but how much would our cost go up by in this case? We can do that by taking $7.50 and subtract 5 from it. So that's the row below minus the row above it. And when we do that, we're going to get $2.50. And if we do that to the next row, we take $10, subtract $7.50, we'll also get $2.50. So all of these costs are actually going up by $2.50. And what that means is that it costs $2.50 for 5 games. So that essentially is our rate of change. So it costs $2.50 to play 5 games. So that means every 5 games you play, the cost increases by $2.50. And we would want to simplify that to find out how much it costs for 1 game. So we can just do this calculation, 2.50 divided by 5. And when you do that calculation, you're going to get that it costs 50 cents for 1 game. Okay, so that's how you would find your rate of change from a table of values. And what I want you to do is pause this video, try this next your turn question on your own, and then come back to the video when you're ready to check your answer. So I got that the rate of change is equal to $1.25 per game. I found that the number of games played is all going up by 4, and the cost is all going up by $5. So rate of change, $5 for 4 games, is equal to $1.25 per game. And one thing to note, these should all be going up by the same number. So make sure you're not just checking the difference between 2 rows and you are checking at least a couple. And now let's find the rate of change from a graph. So we have the cost here, and it depends on the number of toppings. So suppose this graph represents the cost of a pizza. So one way to do this is that you can pick points on your line and then make a table of values. So if we have toppings, number of toppings here, and then our cost, it costs, well, for 0 toppings, it costs $6. For 4 toppings, it costs $9. And for 8 toppings, it costs $12. And if we quickly find out how much our number of toppings are going up by, they're all going up by 4, and our cost is all going up by 3. So our rate of change, I'll just use ROC to represent rate of change, is equal to $3 for 4 toppings. And then we can just do that calculation to find out how much it costs per topping, and it costs 75 cents per topping. So that's one way to do it. Use this graph to make a table and then to find the rate of change. But we can't do it without making a table of values. So looking at this graph, our line starts right here at 6. And that $6, that is actually like a fixed cost or starting cost. That's how much the pizza is without any toppings. So to find the rate of change from a graph, you need to pick 2 points. And I'm going to pick that first point. I'm going to pick this point right here. And what we're going to do is we're just going to draw this triangle underneath. This vertical line in our triangle represents the change in the cost because cost is on our y-axis. And then this horizontal line here of this triangle represents the change in the number of toppings because the number of toppings is on our horizontal, our x-axis. So we want to find out how much our cost changes from this first point that we chose to this second point. And we can do that by looking at our 2 points and seeing how much the cost is. So at the second point, it's $12, and at this first point, it costs $6. So we can do 12 minus 6, and we're going to get $6. So that just means from this point to our second point, the cost went up $6. And now we want to look at how much their number of toppings increased by from our first point to our second point. So again, we're looking at this horizontal line down here. At our first point, we had 0 toppings, but at our second point, we have 8 toppings. So our change in the number of toppings is 8. So our rate of change is $6 for 8 toppings. And if we do that calculation and simplify that, 6 divided by 8 is just 75 cents per topping for 1 topping. And that's the exact same answer that we got when we used the table values. So here's another way that you can find the rate of change but from a graph. And now I want you to go over to the next question and try this question on your own. Pause the video and then you can come back when you're ready to check the answer. So I found that the rate of change is 50 cents per topping. And I found this by picking these 2 points right here. You might have picked 2 different points, but you should still get the same answer. So from my 2 points, I found that the change in the cost is going up by 6, and I found that the change in the number of toppings went up by 12. So when we did cost divided by the number of toppings, 6 divided by 12, I got that. It costs 50 cents for 1 topping. So now let's try a rate of change problem. Carl works at a local grocery store where he earns $8.25 per hour. That means he gets $8.25 every hour that he works. A typical shift lasts 6 hours. So for part A, we need to complete the table of values to show his total earnings for 6 hours. So let's work on this table of values. So we know that Carl earns $8.25 per hour. So for 0 hours worked, that means he should not earn anything. He earns $0. If he works 1 hour, he's going to get $8.25. If he works 2 hours, that would be $16.50. And here I'm just adding $8.25 for every hour. And if he worked 3 hours, he would get $24.75. And here's the rest of the table. So now let's find our rate of change. We know that the number of hours are going up by 1, and our total earnings for every hour, it's going up by $8.25. So our rate of change here is actually just $8.25. And if we just graph this, the hours worked is going to go on our x-axis, and the earnings is going to go on the y-axis. And we need to make a scale, so I'm just going to make on our x-axis that every 2 squares is going to be 1 hour. And on the y-axis, I'm just going to make that every 2 squares is going to be worth $10. And we would need to plot these points. So for 0 hours worked and 0 earnings, you would get this point right here at 0, 0. For 1 hour and 8:25, we can estimate it to be around there, and we just need to plot the rest of these points. And you can see that this forms a straight line. So we can draw a line right through it as straight as we can, or use a ruler if you're creating your own notes. And there you have it, that's our graph. So our last question here asks us, what does the rate of change represent in this problem? So this is a particular scenario where Carl works at a grocery store and he earns $8.25. That's actually our rate of change. So in this case, our rate of change here is just like his hourly wage. So the amount of dollars he earns per hour.